Hello, welcome back to Mr. Allen's fantastic math class. Today we're going to talk about similar triangles and specifically the parts of those similar triangles. So what we have here is an example that you might see on a test or a homework. It's a fairly common one. What they're asking us to do is find the measure of CD, this side right here that has a variable x, and another side CB, which also has the same variable as x. So in order to do that, we have to try to figure out if these two triangles are similar. So the first thing we need to do is figure out if they're similar. So I'm looking at this, and I know the measures of these two, but I don't have numerals there, so I can't use those to find out a proportion. So I might have to use some angles. I notice here that I have two lines that are parallel, so AD is parallel to BE. And I also see that I have vertical angles here. So I'm going to start right there. And I know that this angle BCE is congruent to ACD because they are vertical angles. And then we have to find another set of angles. And so then I remember that if I have parallel lines and they're cut by a transversal, I'll use this segment DE. I know that this angle is an alternate interior angle to this angle. And so now that I've done that, I can see that I have the angle-angle similarity. And so I'm going to write down my similarity statement that triangle ACD is similar to triangle A is going to be corresponding to E. So ECB. And that's helpful so I can set up my proportions. So let's take a look at some proportions that we can set up here. So I know that, well, I want to know what AD corresponds to. A and D is going to be corresponding to EB. And so I want to find out what that ratio is, and that's going to be 4/6. And if I simplify that, that's 2/3. So this right here is going to be my scale factor. So I'm going to use that scale factor to find our variables. And so what I need to do is find out what side DC corresponds to. So DC, or CD, you can name it either way. I see here that DC is the second two, so that's going to correspond to BC. Or CB, you can name it either way. So I'm going to set up a proportion that has DC over BC equaling AD over EB. So let me just change markers here. So my proportion is going to be DC, which is x plus 1, over BC, which is 2x minus 0.5. And that's going to be over AD over EB, which we have already figured out is 2/3, our scale factor. So I'm going to use cross multiplication. So I'm going to multiply 3 times x plus 1 and 2 times 2x minus 0.5. Now I'm going to use distribution. So 3 times x and 3 times 1, so it's 3x plus 3. And then 2 times 2x, which will be 4x, and 2 times 0.5, which is just 1. I will bring the 3x over. You guys see that? So that leaves me with 3 equals x minus 1. And I will add 1 to both sides. And so I will get 4 equals x or x equals 4. But what they asked for, if you remember up top, scroll back up there, they asked for CD and BC. So all I have to do is take my x, which was 4, and plug it back into here. So, sorry for scrolling so much. So if DC equaled x plus 1, then it's going to be 4 plus 1, which is going to be 5. And CB equals 2x minus 0.5, or half. So it's going to be 2 times 4 minus 0.5. So it's going to be 8 minus 0.5, or 7.5. So there's our answers. I can go back up here. So this side right here is going to be 5, and this side right here will be 7.5. So I hope that was helpful. Let me zoom out so you guys can check out this whole thing, or most of it anyway. So we have to set up a proportion, and then solve for x, and then plug x back in to find the sides. So that's all we have for today. If you have any questions, feel free to ask me either in person or on my blog. Thank you very much. Have a great day.